Science. 3. Chemistry. The marvels of chemistry, investigating the building blocks of matter. 1. The nature of chemistry, exploring matter's composition and behavior. Chemistry is a branch of science dedicated to investigating the composition, properties, and behavior of matter. It provides a deeper understanding of the substances that make up the world around us, from the air we breathe to the materials that construct our environment. By studying the interactions and transformations of atoms and molecules, chemistry unveils the underlying principles that govern matter and allows us to manipulate and control its properties for various purposes. Whether it's analyzing the components of a chemical reaction or developing new materials with specific characteristics, chemistry is at the forefront of unraveling the intricacies of the microscopic world. 2. Atomic structure, the building blocks of matter. Chemistry delves into the structure of atoms, which are the fundamental building blocks of matter. Atoms consist of a nucleus containing protons and neutrons, surrounded by electrons in energy levels or shells. The arrangement and distribution of these subatomic particles determine the chemical properties and behavior of different elements. By understanding the atomic structure, chemists can explain the periodic trends observed in the periodic table, predict the reactivity of elements, and comprehend how atoms combine to form compounds. 3. Elements in the periodic table, classification and organization. Chemistry classifies elements based on their unique properties and organizes them in the periodic table. Each element is represented by a symbol and is characterized by its atomic number, number of protons, and atomic mass, sum of protons and neutrons. The periodic table provides a systematic framework for understanding the relationships between elements, such as their chemical reactivity and physical properties. It allows chemists to identify patterns and trends, predict the properties of undiscovered elements, and facilitate the study of chemical reactions and bonding. 4. Chemical bonds, interactions and stability. Chemistry investigates the interactions between atoms and the formation of chemical bonds. Chemical bonds are forces that hold atoms together, determining the stability and reactivity of compounds. Covalent bonds involve the sharing of electrons between atoms, resulting in the formation of molecules. Ionic bonds occur when atoms transfer electrons, leading to the formation of ions that attract each other. Metallic bonds involve the delocalized sharing of electrons among a network of atoms. Understanding the nature of chemical bonds allows chemists to explain the properties and behaviors of different substances and manipulate them for various applications. 5. Compounds and molecules, building blocks of substances. Chemistry examines the formation and properties of compounds, which are substances made up of two or more different elements chemically combined. Compounds exist as molecules or ions. Molecules are formed when atoms of different elements are held together by covalent bonds. Ions are formed through the transfer of electrons, resulting in the formation of positively charged cations and negatively charged anions. The study of compounds enables chemists to investigate their unique properties, such as melting points, solubility, and chemical reactivity, and explore their applications in various fields, from medicine to materials science. 6. Chemical reactions, transformations in new substances. Chemistry explores the changes that occur during chemical reactions, where substances undergo a transformation, leading to the formation of new compounds with different properties. Chemical reactions involve the breaking and forming of chemical bonds, rearranging atoms to create new substances. Chemists study reaction mechanisms, reaction rates, and factors that influence the outcome of reactions, such as temperature, pressure, and catalysts. Understanding chemical reactions allows chemists to design and optimize processes, synthesize new compounds, and develop sustainable technologies for a wide range of industries. 7. Stoichiometry, quantitative relationships and reactions. Chemistry utilizes stoichiometric principles to calculate the quantitative relationships between reactants and products in chemical reactions. Stoichiometry allows chemists to determine the amount of each substance involved in a reaction, predict the yield of products, and understand the conservation of mass and atoms. By applying stoichiometric calculations, chemists can optimize reaction conditions, ensure the efficient use of resources, and design chemical processes with precision and accuracy. 8. Acids and bases, proton donors and acceptors. Chemistry investigates the behavior of acids and bases, which are essential substances in chemical reactions. Acids are compounds that can donate protons, H+, to other substances, while bases are compounds that can accept protons. The study of acid-base reactions and their equilibrium provides insights into pH, buffer systems, and neutralization reactions. Acids and bases play crucial roles in various fields, including biochemistry, environmental science, and industrial processes, and understanding their behavior is fundamental in many chemical applications. 9. Thermodynamics, energy transfer and transformations. Chemistry studies the transfer and transformation of energy in chemical systems through the principles of thermodynamics. Thermodynamics encompasses the concepts of heat, work, energy, and the laws that govern their interconversion. It allows chemists to understand the heat flow in reactions, the spontaneity of processes, and the relationship between energy and chemical potential. Thermodynamics is essential for optimizing chemical reactions, designing energy-efficient processes, and predicting the feasibility of chemical transformations. 10. Kinetics, rates and factors of chemical reactions. Chemistry explores the rates at which chemical reactions occur and the factors that influence reaction rates. Kinetics investigates the mechanisms of reactions, the role of catalysts, and the effects of temperature, concentration, and surface area on reaction rates. Understanding reaction kinetics enables chemists to control reaction rates, improve reaction efficiency, and design reaction conditions for specific purposes. It is essential in fields such as pharmaceuticals, materials science, and environmental chemistry. 11. Organic chemistry, carbon-based compounds. Chemistry focuses on the study of carbon-based compounds, known as organic chemistry. Organic compounds are central to life and form the basis of countless substances, including hydrocarbons, polymers, pharmaceuticals, and biomolecules such as proteins and carbohydrates. Organic chemistry investigates the synthesis, properties, and reactions of these compounds, allowing chemists to understand the intricacies of living systems, develop new drugs, and create innovative materials. 12. Inorganic chemistry, properties of inorganic compounds. Chemistry examines the properties and behavior of inorganic compounds, which include metals, minerals, and non-metallic substances. Inorganic chemistry investigates the structures, properties, and reactivity of these compounds, offering insights into their applications in areas such as materials science, environmental remediation, and catalysis. It complements organic chemistry by providing a broader understanding of the full range of compounds found in nature and synthesized in the laboratory. 13. Analytical chemistry, analysis and quantification. Chemistry develops techniques and methods to analyze and quantify the composition of substances through analytical chemistry. Analytical chemists employ various tools and instruments, such as spectroscopy, chromatography, and mass spectrometry, to identify and measure the components of a sample. This field plays a vital role in quality control, environmental monitoring, forensic analysis, and the advancement of scientific knowledge by providing accurate and precise data. 14. Physical chemistry, bridging physics and chemistry. Chemistry applies principles of physics to understand the physical properties and behavior of matter at the atomic and molecular level, known as physical chemistry. Physical chemistry investigates phenomena such as quantum mechanics, thermodynamics, and spectroscopy to explain the behavior of chemical systems. By combining physics and chemistry, physical chemistry bridges the gap between the macroscopic and microscopic world, providing insights into the fundamental processes that govern matter. 15. Environmental chemistry, impact on the environment. Chemistry investigates the impact of chemical substances on the environment through environmental chemistry. This field examines the fate, transport, and transformation of pollutants, the measurement of air and water quality, and the development of strategies to mitigate pollution. Environmental chemists play a crucial role in identifying and assessing the environmental impact of chemical substances and developing sustainable practices to protect ecosystems and human health. 16. Materials science, synthesis and characterization. Chemistry explores the synthesis and characterization of materials through materials science. Materials scientists investigate the properties, structure, and performance of various materials, such as metals, ceramics, polymers, and composites. By understanding the principles of materials science, chemists can design and develop materials with desired properties for specific applications, including electronics, energy storage, and biomedical devices. 17. Biochemistry, chemistry in biological systems. Chemistry investigates the chemical processes and substances involved in biological systems through biochemistry. Biochemists study the structure and function of biological macromolecules, such as proteins, nucleic acids, and carbohydrates, as well as the metabolic pathways that underlie cellular processes. Understanding biochemistry is crucial for advancing our knowledge of diseases, drug development, and biotechnological applications. 18. Nanotechnology, manipulating matter at the nanoscale. Chemistry plays a crucial role in nanotechnology, which involves manipulating and controlling matter at the nanoscale, 1/1,000,000th of a meter, to create new materials and devices with unique properties. Nanotechnology has applications in various fields, including electronics, medicine, energy, and environmental remediation. Chemistry provides the foundation for synthesizing nanomaterials, understanding their behavior, and designing nanoscale systems with tailored functionalities. 19. Medicinal chemistry, designing new drugs. Chemistry contributes to the development of new drugs and pharmaceuticals through medicinal chemistry. Medicinal chemists study the interactions between chemical compounds and biological targets, aiming to design and optimize drugs with enhanced therapeutic properties and reduced side effects. Medicinal chemistry combines knowledge from various disciplines, including organic chemistry, biochemistry, and pharmacology, to create innovative treatments for various diseases. 20. Forensic chemistry, scientific evidence in legal cases. Chemistry assists in forensic investigations by analyzing evidence such as fingerprints, DNA, and chemical traces to provide scientific evidence in legal cases. Forensic chemists employ analytical techniques to identify substances, determine their origin, and establish links between individuals or objects. Their work plays a crucial role in criminal investigations, providing objective and reliable scientific evidence to support legal proceedings. 21. Everyday chemistry, impact on daily life. Chemistry is present in our daily lives, often unnoticed but essential to various aspects of modern living. It influences the food we eat, the water we drink, the clothes we wear, and the materials that surround us. Chemistry is involved in cooking, cleaning, personal care products, and energy sources. By understanding the principles of chemistry, individuals can make informed choices, appreciate the impact of chemical substances on their health and the environment, and contribute to sustainable practices. Thanks for watching. Please like, share and subscribe, and comment below if you agree, or would like to add your thoughts.